Okay, ready? Okay, for the first presenter, the title is Special Prediction of Flood Probability in Human Watershed using loss integration and precision tree algorithm. The author is Yusri Koyuriski, Lutfi Renda Ramadan, and the guy is Nur Tanama and so on. And this paper will be presented in person by Yusri Koyuriski.
Ini berarti yang belum terbaru. Kalau misal ini presentasinya yang dulu ya.
Is the presenter already present?
Terbaru. Oh ya, misalnya.
Okay, so maybe the time is 15 minutes. Are you ready to do the presentation? Yeah. You may start the presentation and the time limit is 15 minutes, including the question and answer session.
Yeah. Okay, good evening everyone. My name is Sadiq. I'm the representative of my team. I'm from Gujarat University and I'm here. Thank you. First of all, I want to say thank you for the opportunity and my name is And I'm here, I would like present about special prediction of flood probability in Gujarat University. Using of this prediction in the tripoli. Next slide, please. Here is the table of contents for our presentation, starting with an introduction, method, result discussion, and the last one is conclusion. Here we start with introduction. Flood with presentation is the flood. Flood is a commonly natural disaster that occurs over Indonesia. And even in some areas, it becomes a seasonal disaster. Flood is the condition when the rainwater accumulates and overflows onto the land. And flood usually happens during a rainy season, and when it occurs on the large scale, it becomes dangerous and causes a heavy disruption to property and complete a lot of numerous lives. Based on the case, early mitigation are needed, especially for the areas that have high potential for flood. One of the ways that we can use is by predicting the areas that will get especially for flooding using integrated object data sensing and help of the IS or geographic information system. As I mentioned before, in this study we are trying to predict the flooding. And this study we are using remote sensing imagery as our main data, and what is the emerging data to be used in this study? First of all, we use the remote sensing data because the first one we can do the large scale of monitoring, which is more area can be covered in one process, and then the second one is we can enable to have a data fusion or integrated outstanding data, just like we do in our study. We have a variable that obtained from the processing extraction from the remote sensing, and then from the variable we are processing using a machine learning, which is low distribution and decision algorithm, and then we get a full prediction model. Check this. Where the next is the study area. Our study area is located in Juanda Watershed in Central Java, which is the Juanda Watershed covered some several administration areas like food integrity, patent integrity, and global energy. And the selection of this study area also we have some reference that this area that covered by Juanda Watershed is historically studied by sun. Next, please. Where this is our data source and full and variable that we use from extraction from the data. I will say first. The data first one is SNL2 imagery, the data elevation model allows, shared by Juanda Watershed. Rainfall data, flood and rainfall point is for the training and testing data, different network. Those we are using ArcMap, NV, RStudio, and variable. We can talk about it in the next slide. Next, please. Okay, this is we can say this is the preliminary result. Is a tentative of variable that we have extract from remote sensing imagery. Just like you can see, the first one is variable landform. We extract from digital elevation model Alas Pulsar and imagery Sentinel. And then the elevation also from digital elevation model using the from river data network from geoportal in Jawa Tengah. And then the normalized difference in vegetation index from Sentinel to B. And then the E quantity is normalized different water index from Sentinel to B. The land cover from Sentinel B to also. The next slide. Okay. From the rainfall, we got the processing from the data we call trips. It's a global data from rainfall, and we have extraction using GWR or geographic radius radiation. And then the slope we extracted from the data elevation model of Sparta, and topographic radius index we also get from them. And the last one, the density from the river data network. These are our flowchart of our study. First one, from the raw data, we have harmonizing, or we do the sum. The raw data is have a different spatial resolution, so we do the harmonizing data for all the data have the one resolution spatial. So and then from the raw data we have the all variable that we have mentioned before, and then from all four variable, then we using a machine learning to get a prediction model of flood. But this is I think the simple ways from our workflow. We have divided for 4 sections. The first one is harmonizing data. As I said before, all of data have different spatial resolution. Then we have to change in the one resolution spatial. And the second one is extract training and testing data. Is for we training the data from the machine learning, and we are testing the model. Next, we build the model and predict the photo probability. That's when we measure the model performance to see the accuracy of the model that we have made. Next one, please. Okay, and then we do the result. This is our main result. Photo probability using logistic regression. As you can see, this table we get from the processing from RStudio. This is called the all variable that have significant to flood occurrence. As you can see, the variable that have asterisk mark is the high significant cause for flood. The significant variable are elevation, HDI, and WI, land cover, and rainfall. The other variable is still used, but have to significant effect on the model. So the level generation model has no bias toward the specific direction because the median field of the deviance residual across 0. Okay, next one is the probability using decision tree. And from this decision tree branching, we know the variable show in the tree only give a base split, which is the elevation, rainfall, drainage activity, and topographic radius index. The other variable is stored on the nested tree and not used because it will make a model overfitting. The higher position of the variable on the tree show that the variable have a higher importance or the most significant for the model. Next slide. That is the comparison. Sorry, there are I want to change this. This is the comparison of the map model from the language aggregation and decision tree. From the visualization of the map, maybe you can see this is the blue one is the potentially high of flood occurrence. Maybe you will see the flood of the map is not to have any kind of difference, because maybe we can next the slide to see one reason. So the maps, maybe you can see the map is no lot of difference because on the model performance that we measure from the code of the model has shown that AUC value or area under the river from receiver operating characteristic has the similar result or the value from the decision tree or logistic regression. As you can see, the code model approach number 1, which is the code of model, have a grade to be modeling the flood prediction. But as we see the closest, the local segregation have a more value or the higher value. You can see the deviation tree value, accuracy value just only 0.92, and the local segregation is 0.94. Okay, this last the forward question. Variable with the high significant for local segregation including elevation, NDVI, and NDVI, and transfer and rainfall. This variable that give best slate in decision tree model are elevation, NDVI, NWI, and cover and rainfall. Both local segregation and decision tree are good performance when processing the flood prediction model, even though the prediction model has something better. And also from the modeling that we do, both of the model has better to do modeling for the flood prediction. Maybe the effect of the result just depending from the quality of the data or the variable. So maybe in the next future study, we also need the field validation, going to the field to see if the place are really have a flood in the real time. Okay, maybe this for me. I would say thank you for your attention. Maybe you have some question.
Okay, thank you. Yeah, we still have 4 minutes for the question and answer session. Maybe some of you have question for this presenter, Mr. Yusuf. Okay, maybe if there is question, maybe I have some question actually. Also, you predict the flood, whether it's flood or not. But I'm still curious. Is it you mentioned you determine by using the latitude, longitude, or certain area or whole area for the prediction?
Prediction we are using the watershed administrated only on administrated area, but just from watershed the area from
also the area,
yeah,
just latitude, longitude, and then you predict whether it is.
We just use the area from watershed, the whole watershed.
Okay, and then about the flow data, is it from the previous, as you mentioned that it is not a real time. So I assume that this flow data comes from the previous history or previous year. Is it correct or?
From the prediction of flood visits, we use the flood. We use the machine learning, so we get training and testing data from the global data. Flood global data from we extracted from Google Earth Engine.
Oh,
yes, because from that we also I say that it's not maybe we in the future study we need a validation to the field so we can see the real if the area has the flood or not.
Okay. I think that's not my question. Maybe other participants or attendees who still have any question? Okay, I think if there is no question, maybe you can conclude your presentation and then we can move on to the next presenter.
Okay, thank you everyone for your attention and that's all for me. I'm sorry if there some breaks and thank you.
Okay, okay. Okay, maybe for the next presenter, maybe you can prepare for your presentation. The paper title is Analysis of Effects of Image Augmentation with Image Enhancement on Fish Image Classification using Convolutional Neural Networks. The author is Pak Muhammad Azhar, Nani Suciati, and Hasri Matika. Anyway, yeah, we can start.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon. Any audience? Thank you so much for listening. It's also time for me to be able to present The result of my research is a title analysis effect of image augmentation, image enhancement, on this image classification using conventional learning. So, this is the introduction of this paper. So, my name is Adam Hatta, and my advisors from Fidelity and Profitability. So, this is the table of content of this presentation. Introduction, granted for methodology, results, and conclusion. Okay, next. So, first, I want to talk about the background of this research, which is CNN. So, CNN is one of the deep learning methods that can be used for classification. CNN can execute complex data algorithms to emulate human imagery. But there's a drawback. CNN depends on the pixels of the image to classify when there's an image, which is the contrast is too low or it's dark. However, CNN will have a difficulty recognizing the image. And this means CNN also depends on the large amount and quality of the data. So, this is a tool described the effect of the augmentation method with image enhancement on base image classification using CNN. So, we use the augmentation to increase the number and variation of the training data. So, we use two techniques of image enhancement. First is histogram equalization or HP, and contrast limited adaptive histogram equalization or CAD. So, these two enhancements intend to emphasize the difference between the dark and the light colors in the image. So, the objective of this research is to determine the effect of the augmentation by HP and by image enhancement on this image classification using CNN. And for the benefit, the image augmentation with image enhancement can improve the performance of the CNN model because HP and plugin can generate new effects of data. So for the related works, we use three related works as the main reference. The first one is multilateral residual network, PGNet, office species classification. So in this paper, the authors propose CNN architecture of multilateral residual PGNet, which use PGNet as a backbone, and then combine it with some components, which are asymmetric convolution, multilateral residual, reservoir block, and mesh normalization for base image classification. So this paper also uses the same dataset as ours, which is this dataset. Okay. So the second one is image enhancement and classification of CFRDAM using convolutional neural networks. So in this paper, the authors propose the CNN architecture that combines some image enhancement, like colors, contrast, lighting, and image sharpness enhancement with image classification. But however, the use of this architecture is only on images that have been classified previously in open source data architecture and get the wrong classification result or misclassified in the image. And the third one is hybrid deep learning approach for automatic piece classification. So in this paper, the author proposes piece classification system that can work manually underwater according to its natural habitat. So in this research, is a hybrid deep learning model with a VG16 written model, which is used for feature extraction and study ensemble, which is used for detecting and classifying the images. Now, for the methodology. So this is the process of my research, of our research. So first we split the dataset into 70% training data, 5% validation data, and 20% test data. We use the enhancement on the training data and generated two new training data, which is the HP augmented training data and Plate augmented training data. These two enhancements have twice of the amount of data of the original training data. So in system we have three training data: the original one, the HP augmented training data, and the Plate augmented training data. We also use CNN architecture with retrain three pre-training models and without pre-training models. The pre-training models are version 50, PG16, and exception. For every architecture, we will train by the three training data. And for the training process, we use the optimizer and stroke with batch size 32 with overhead on the top and the checkpoint and the rate of 10 to the power minus 3 and 10 to the power minus 1. And for the evaluation, we compare the accuracy of each model. So this is the data set that we use. This is a business data set, which consists of 8 classes each. There is standard channels with 500 images, and the 240 images. Unit starts with 240 images. Ini BA 252 images. Audio promotion starts with 331 images. Audio promotional papers with 564 images. Just regular with 544 images, and banners, models, and sets with 577 images. For every image have a size of 390 times 520 pixels. Next. So this is the architecture of the CNN we use. Converted is CNN with other 15 models, which is consists 5 and 4 convolutional layer. And for converted is CNN with 15 model. So we change the convolutional layer with the design asset. So briefly, this is the HCM fiber, and for the HE, central visualization. First, we calculate this histogram of the image, then we normalize the histogram, and then we set the pixel value. Meanwhile, for the plugin, first we have to divide the image into n and tiles, and then for every tiles, we need to calculate the histogram, and then we include the histogram and normalize. Then the last one, we use linear exponential to combine the tiles. And this is the result. So for the result, this is the result of the image enhancement. So the left one is the original image of sensor class, and on the middle one is the HE enhanced image from the original image, and the right one is the plugin enhanced image from the original image. So this is the accuracy of the CNN with present 50% models. So we got HE with learning rate 10 to the power minus 3 with an accuracy of 100%. This is the best for this architecture. The next one is the CNN with exception different model. So in this architecture, the next model is the original model. As we can see, there's the augmentation of the HE and the plugin model. Reduce the accuracy from the original model. So we try to change the optimizer and add some level layer. So this is the result when we change the optimizer and add some level layer. As you can see too, the accuracy still below the original layer. So it means it can go by 8 down step. So when we use the augmentation, the care of the every image, every class will be interested. So it can be very imbalanced. Okay, the next one is the CNN with PGG16 return model. So in this model, in this architecture, this model is a plugin model with 10 to the power with the accuracy 99.69%. And the last one is the CNN with return model. So in this architecture, the first model is the HK model with 10 to the power minus 5 learning rate with 97.1%. Now for the conclusion. Image communication with image enhancements, especially HM plugin on this research can improve the performance, but not for every model. And HM plugin can use image augmentation because both methods can generate new images that can be used as variation of training data. And for the best model, this research is the CNN with SNAP 50 model, HE augmented training data and learning rate of the power of S3 with 100% accuracy. So this is the references for the 9 inference. Next. Okay, maybe that's all from me. There's a question.
Okay, thank you for the presentation. Maybe for the audience, do you have any questions? Yes.
What do you use in your organization? Did you copy your data and then you use program testing as histographic collection, or you use metadata generator and then the processing you set the histographic collection?
Okay, thank you for the question. Answer it. So I use the enhancement. We basically I copy the data, the original image, then I use the enhancement, and then we write the images to become a new image like that. Is that clear?
Okay, thanks.
Thank you.
Okay, thank you. Maybe any other questions from the audience? Yeah. Okay.
For the conclusion for the first point, it said HE and translation can get a higher activity, but not all model. Is it, and is there any explanation why some model accuracy is improved when it is?
So the question is, why is the PhD and Batik can improve the other model, but not for this one? Okay. We will answer it. What we answer it. So this may be because there's a technique of CNN. This is not sorry. So this is the CNN with the exception written model, which is reduced in the accuracy. So I think the written model cannot.
If you cannot found the
Yes.
the words in English, you can use. Yeah.
I think the present model.
You can use Indonesian if you are more comfortable with that. It's okay. It's okay. Yeah.
What is it? Handle. So I think the decision with exception present model cannot handle very imbalanced data. So every architecture will be different result. So this we have to change. We have to choose the right architecture with the right data set. Is that clear? Thank you.
Okay, thank you. We still have 2 minutes. Maybe any other question from the audience? Okay, maybe last question from me. Have you ever considering the running time for each models? Have you considering the running time? Which one is the fastest one and also have higher accuracy?
Okay. Thank you for the question. So answer I have, but I think I don't see this. Maybe for me, from this research, the best one is that the HE model with sensitivity reason model with learning rate of 10 to the power minus 3. So there's the conclusion that I use this is the best model.
Okay. Okay, thank you. Maybe we still have 1 minute. Maybe last question. Okay, I think maybe if there is no question, you can conclude your presentation.
Thank you so much. And that's sorry if there's a mistake. And thanks for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Okay, thank you. Okay, we will continue to the next paper. The title of this paper is Enhancement Techniques on Deep Learning based Mammography Classification for Breast Cancer Detection. The author is Ani Yuniarti and also Karton Swida. Okay, so this presentation will be done online. So maybe we can, I think we can see the presentation, and then because the author is not Christian, maybe next we continue to the next presenter. Yeah, we can start the videos for the documentation. That's the presenter already present.
Good evening. I will present my paper that entitled Enhancement Techniques on Deep Learning Based Mammography Classification for breast cancer detection. My name is Ani Yuniarti, and the second author of this paper is Katon Suida. I apologize I cannot attend the conference offline or directly online because we have some circumstances. We are from Department of Informatics, Institut Teknologi 10 November, Surabaya, Indonesia. I will present the introduction first and then the proposed method, followed by the result and conclusion. Let's begin with some introduction. Breast cancer is a common and potentially life-threatening disease. It ranks second in cancer-related deaths among women. Based on various studies, mammographic density has been recognized as a significant factor for breast cancer. Mammographic density describes the amount of fibroglandular tissue compared to fatty tissue within the breast. Fibroglandular tissue absorbs an X-ray and appears as a bright area in mammography. Since most cancers also absorb X-rays at a similar rate to fibroglandular tissue, cancer will appear as a white mass in mammography. Classic CAT systems or computer-aided diagnosis system, which rely on traditional machine learning approach with predetermined characteristics, have been shown that these CAT systems do not significantly improve diagnosis accuracy. This paper aims to use a model of the convolutional neural network algorithm or CNN to perform the mammography image classification task. The most significant contributions on this research are, first, analysis of the best type of image enhancement method for mammography images. The second, qualitative and quantitative testing of types of deep learning models in breast cancer classification after training if improved image datasets using adaptive contrast smoothing and gamma sharpening enhancement is provided. Let's continue to the proposed method. This is the proposed system design. First, the mammography images will be the input to the system. There will be three enhancement techniques that will be applied in this research, namely adaptive contrast smoothing, gamma sharpening, and adaptive gamma sharpening. Each of these enhancement techniques will be applied to the data or mammography images. After that, we will proceed to the data augmentation, and we will have two sets, which is trained data and validation data set. And then we'll use some deep learning models and fine-tune the models, and it will result in a fine-tuned models. In the other, we have also a test data, which is not included in the training, and we will use this data in test data process using the fine-tuned models, and it will result in classification report at the end. Each of the enhancement technique has several sub-processes. First, the adaptive contrast smoothing will apply contrast-limited adaptive histogram equalization or CLAE and apply average smoothing filter followed by median filter. The second enhancement technique is gamma sharpening. First, it will apply gamma correction, and then it will apply unsharp masking. The last one, adaptive gamma sharpening, it will begin with applying CLAE as well as adaptive contrast smoothing, and it will followed by applying the gamma correction. After that, we will apply unsharp masking and apply median filter lastly. In this design and development, we will use the MIAS mammography dataset, which has 124 mammography images divided into two classes, 55 images in the benign or non-cancerous class, and 69 images in the malignant or cancerous class. In order to increase the variation and training data volume, data augmentation using rotation is employed to create new variations from the existing data. We employed varied angles of rotation to the original data, which is a range of 0 to 360 degrees with step size of 8 degrees. After the augmentation, we will reach data that reach 5,175 images. This allows the model a more significant variation in the training data and enhance its ability to recognize patterns and features in mammography images. Next, the data was divided into 3 parts with a proportion of 70% for training, 20% for validation, and 10% for testing. The framework that used in this research is a TensorFlow framework, and it will be used to train, validate, and test the CNN model. The CNN models that's trained using 8 different architectures, namely Inception ResNet v2, Inception v3, DenseNet 169, MobileNet v2, VGG16, ResNet 101, VGG19, and ResNet 50. First, I will discuss about image enhancement. The first technique is called adaptive contrast smoothing. It will combine the contrast-limited adaptive histogram equalization, image smoothing using blur filters, and noise reduction using median filters. The aim of these processes are to enhance the contrast, to smooth the images, and reduce noise. The goal is to improve the image visual quality and interpretation, particularly by enhancing fine details and reducing noise artifacts. We see from this image, the left side is the original, the right image is the image after applying the adaptive contrast smoothing. The second technique is gamma sharpening. It will combine gamma correction with image sharpening to enhance sharpness and details. Gamma correction adjusts the brightness and contrast of the image by modifying the gamma transformation. Image sharpening techniques like unsharp masking improve clarity and details in the image edges and structures. The third technique is called adaptive gamma sharpening. It is a technique that combines the contrast-limited adaptive histogram equalization, gamma correction, median filter, and sharp masking. The first technique, which is contrast-limited adaptive histogram equalization, enhances local contrast. Gamma correction adjusts the brightness and the contrast. And finally, the median filter will reduce the noise. Finally, unsharp masking will sharpen the image by enhancing edges and structures. We can see from this image that the original will have a more good quality image with sharpness, interpretability, making them suitable for visual analysis and classification tasks. Next, we will discuss the result of this research. Using quantitative evaluation, we measure the accuracy of the classification task using several deep learning models. Base classification is by using the original deep learning model without image enhancement techniques. We can see from this data, for example, using Inception ResNet v2, your base classification reached 78.76% accuracy. And after we apply the enhancement technique, for example, adaptive contrast smoothing, the accuracy value reached 79.40, which is higher than the base one. As well as that, gamma sharpening technique also increased the accuracy score, which is 80.04%. Lastly, adaptive gamma sharpening, it reached the highest improvement, which is 82.83, using the first deep learning model. We applied to several other deep learning models, which are Inception v3, DenseNet 169, etc. And we can see that all the enhancement techniques can improve the accuracy score based compared to the base classification result. For example, inception P3 using adaptive gamma sharpening, it can reach 86 compared to 81%. DenseNet using gamma sharpening can reach 91.2% compared to 83%. MobileNet 89 compared to 87, etc. We mark the highest value of accuracy in bold letters like this. So we can see from this table that applying some enhancement technique to the input may increase the accuracy score of classification in mammography images. Using the same quantitative evaluation but different metric, we use the AUC under area curve. We can see that also in this metric, all the performance reached by the enhancement techniques are higher than the base classification one. In conclusion, we can conclude from this study that we have successfully developed a mammography classification system using deep learning techniques and image processing methods to improve breast cancer detection or classification. The results show that the adaptive gamma sharpening method significantly improved the classification accuracy in several models, with the highest accuracy reaching 98.707% in the VGG16 model. Additionally, this research demonstrates that the adaptive gamma sharpening method effectively distinguishes between cancer and non-cancer cases, with the highest AUC reaching 98.06% in the VGG16 model. By combining deep learning techniques and image processing methods, this research successfully enhanced the performance of mammography classification models in breast cancer detection. These findings prove that the image processing methods, such as adaptive gamma sharpening, hold great potential in improving the accuracy and reliability of breast cancer classification. Okay, thank you for my presentation. Thank you very much for the attention. Good afternoon.
Okay, thank you. Because the author is not present, so we were unable to ask the question. So maybe we can move on to the next presenter. The title of paper is Convolutional Neural Networks with Multimodal Pooling for the Efficient Stack Analysis in Image of Arbitrary Settings. The author is, sorry if I'm not correctly spell your name, Tifu Kuruswa, Jen Delacroix, and Tohariyama, and also Koyana Isbiadia. Okay. Are you ready to listen? Yes. Yeah. Okay. Can you? Yeah, we can start the presentation. Your time is 15 minutes, including the question and answer session.
My name is Shunpa. I and we are all affiliated to research technologies here. So our design focuses on using large-scale pooling to efficiently detect hidden data in images of arbitrary size. Here, before we can continue, let's say that what's of time 8 works from the introduction to the future research what's aiming for. Its introduction allow me to start from introducing what mammography is. When we talk about signography, we hear about securing data by hiding it within the content of another digital component. So to avoid, in general, people used to have secret communication for the sake of privacy and confidentiality of information. That's why people use some data hiding paradigms like signography, like cryptography, like watermarking. And for us, we focus on signography, but the reverse operation of signography. Here it means that we are trying, as signography tries to hide the secret information. For us, we try now to detect whether images have hidden information in their content. In fact, here we are trying to address the problem of malicious communication that can happen among people who can hide it, because when they embed the secret information in the content of images, which is not easily to detect, because for those people who hide information, their objective is to make it safe. The safety are meaning that they try to make it not visible to anyone who can check those images. So for us, we try not to do that. So for the problem that we are trying to address with this research, we are trying to address the problem of signals within images of sizes, because images are not supposed to have the same size. In fact, when we say that we focus on one size of image, for instance, in the case of 256 or 256 as a standard size of image, we may be wrong, because all of the people will not be forced to use the same the same size of images. That's why within our research, we're trying to address the issue, like to increase the analysis of images of different sizes. So to do that, we're using convolutional neural network as for other previous research, because we're not starting from scratch. But we are trying to focus to add new features that can improve the accuracy in detecting the presence of secret messages, or secret data, or secret bit streams within images, regardless of the size. For the existing works, there are really several existing works that use data augmentation, that use pre-trained models like let's say the Cyanus to detect the presence of hidden data within images. But different techniques also, such as high-pass filters, absolute value functions, and others are trying to improve this. So we depart from them and add a few features to the existing models, then we try to increase the accuracy in detecting the existence, the presence of secret messages, secret bits. Because here, when we're talking about secret message, you are not really focusing on a specific type of message, but we're checking the originality of the image, whether they have not been added some secret bits which are not desired for the original messages. Next. For our method, we summarize it with this structure to say, just by inputting image that was taken by random. This image was taken from random. So, different to the existing algorithms that are using the standards, like the preset data sets. For us, we try to test our method with, of course, those images that have been saved before that even others use, and also we try to use the images randomly taken. Then we were trying to hide information, then we were trying to see whether we could detect the change in that image. So we really focus on using parts in pink there on our graph, that where we use partial firing polling module that is able to receive the, can go to the next. That here, this spatial polling module that helps in adapting the images, the features of different sizes, then convert them into one vector feature, one feature that can be interpreted, easily interpreted. Here, we use this spatial polling module because it has the ability to give an output or to generate a fixed length feature for any size of image used for input as input. So here also this SPP uses multi-level pooling to effectively detect the object information. Here, since input is of any size, here, this type of module that we are including is helping much in performing the feature aggregation for any scale or size of image, because we are just focused on getting or generating the feature, the fixed length feature. For experimentation then, as I introduced before, we used images from the BOSDES, which is our signographic system dataset, which is generally available to the public for the experiments in signographic experimentations. So this model was referenced in reference 17 of the paper, and also we have used the signographic method that are known to be hard to detect. Here we are saying that they are hard to detect, and we use this method because they have been proven by previous researchers in previous research works, that these ones, as they are classified as adaptive signographic algorithm, they are hard to detect. Here, when I talk about adaptive, please allow me to clarify it, because people, images are made of pixels, numbers. So there are some formats that they can use, people can use to hide information. For instance, they can detect the least significant bit. They can set the pixels into binary systems, then they take the least significant bit, then they use them. Those are commonly known algorithms. But when it comes to this adaptive, the signographers are using adapting images, then they hide the data by random. That's what I would say. There is no common formula to detect the signographer within these three types of signographic algorithms. Second motivation of using this algorithm is that commonly within the field of technologies, it is hard, it is a common problem to detect the data that have been hidden with a low payload capacity. If I talk about capacity, I mean small number of bits they add. For instance, one can take image and put 10 bits. You see that is a small payload. That's a small size of image, secret image. But another one can use thousands of bits. Those ones can be easy to detect because they are a lot. So that's why to address that problem of commonly known problem of low payload detection, we use 0.2 and 0.4 payload capacity to check whether we can easily detect with our algorithm. So to evaluate, we use the accuracy, the classification accuracy, the detection accuracy, here referred to as the SCC. So for our results, we have compared our work to the two previous methods, and we could here we could get an improvement. Here we can say we saw that in general we could improve the existing method within a range of 3.46 to 9.93. That range of improvement for accuracy. You can see here in this table, we have highlighted the highest values within each row, because here we have been here for image size, where we are saying that we were testing images of size 5 500 rows above 500 rows means the row 500 rows and column 500 rows and also different sizes. So we have seen that images with homogeneous dimensions within equal row and column within those images would yield the improved accuracy. So for conclusion, we can say that our method use the SPP module for adopting the images of different sizes. We could yield the best accuracy compared to the two previous methods to detect the steganography algorithms. I mean, stenographically hidden data within images. So for future research, we'll try to use another data set which is called Greenhouse Technographic algorithm system, POS, known as POS, to check whether also detect. And also we'll try to locate the exact pictures that will have been altered by a technographic algorithm. Thank you very much. This is all of our
Okay, thank you for the presentation. We still have 3 minutes for the questions. Maybe any of you have some questions? Maybe so. I have some questions, maybe just some clarification. Maybe I might be wrong. So I saw in your presentation you say about the fixed level features, right? So I just get the idea what happens about the image that is smaller than the fixed line image, and then the image that is bigger than this fixed line features. How you can change or maybe transform the image into fixed line features? Yeah.
Thank you very much. For that, we use a component of the method of CNN. So it's padding. Well, padding, if we have small size, we pad it to make it a bigger size. And if it's small, we split it into small chunks and we make it the size we want.
Okay, so it means that is there any possibility that some data loss, for example, or yeah, it is just basic padding mechanism?
In fact, for that, we try to reduce the image into very small size, like 8 to 8, then we pad in a uniform. So the variation of the data is only the amount of illustration.
Okay, actually, thanks. Okay, any other question for this presentation? Okay, maybe if there's no question, we can conclude your presentation and take applause for Mr. Yes, thank you. Thank you. Yeah. Okay, thank you. Yeah, we can move on to the next presenter. The paper title is multi-level classification of student feedback data using BERT and machine learning methods. The author is Hamzah Setiawan, Kastin Pratika, and also Ahmad Saiku. The author will do the presentation by online. Is it live in Zoom or video?
No, I think so.
Okay, Mr. Hamzah, are you ready to do the presentation?
Yes.
Okay, yeah, you will have 15 minutes for the presentation, including the question and answer. Okay, yeah, if you are ready, you can start your presentation.
Okay. Assalamualaikum warahmatullahi wabarakatuh, and good afternoon. Here I will present my article and title Multi-Level Classification of Student Feedback Data Using BERT and Machine Learning Methods. Next. Yes. Studying student feedback is essential for educational institutions to provide good service to their student. The main purpose of evaluation is to improve the service offered to students through the interest monitoring information system. The guardian of each learner shall provide feedback on infrastructure and learning service so that the educational institution can improve its service. In addition, the purpose of evaluation is to investigate student behavior and receive response from the appropriate department to ensure the successful delivery of student service. Automatic classification of student feedback is necessary to improve response time and service quality. Student feedback shall immediately follow the service to the relevant department. Therefore, the automated system classifies the feedback according to the unit handling, prioritizing the most rapid development of the system. Each student feedback can be handled by more than 2 units should the problem include multi-level classification. There are 4 topics that will be discussed in the introduction. Number 1, quality college. In the learning process, students also expect decent administrative service so that they can study well and get certification. Number 2, handling student. Handling student complaints. Student complaints are feedback on service quality to maintain student trust and engagement as user of education service. Number 3, opinion identification. Previous research focused on identification extreme opinion in terms of price and complaint from customer review to understand their true opinion about a product or service. Number 4, customer complaint analysis. Preview research analyze customer complaint with multi-class data using the student learning feedback service to category complaint based on relevant unit, including in multi-level classification problem where claim can be related to more than 1 unit. Next. This system diagram describes the use of word and machine learning method for multi-level classification of student feedback data. It includes data collection, processing, bit coding, feature extraction, model training, evaluation, development, and interactive improvement to build a robust and accurate. In this study, we use the indexing method to retrieve data from the database of the student information system. The data cover the period from 11 February 2021 to 30 December 2021 and include student feedback collect during tutoring meeting with their tutors. Student feedback is used to evaluate the service offered by universities work unit and to provide feedback and advice on what student experience across all university work unit. The dataset used in this study contains 3,233 record filter from a large dataset that originally contained 9,380 record. In processing, there are 5-step perform. Number 1, case folding. Case folding, also known as text normalization, involves converting all text to lowercase of uppercase to ensure consistency and remove and potential discrepancy caused by different letter case. This step helps to treat word with the same spelling but different case as essential. Number 2, data cleaning. Data cleaning involves removing irrelevant or noisy information from the text. This can include removing special character, punctuation mark, URL, and any other symbol that do not contribute to the overall meaning of the text. Data cleaning helps reduce the dimensionality of the data and focus on the essential content. Number 3, stop word. stopwatch are removed from the text data to reduce noise and improve computational efficiency. Number 4, word conversion. Word conversion technique involves transforming word into a standard or canonical form. This step help to that different variation of the same word as identical. Number 3, lemmatization, similar to steaming, reduce word to their base form, but it takes into account the context and applied morphological analysis. Next. After the data is pre-processed, the data is embedded using the BERT methods. The classification in carried out using machine learning method include SVM, KNN, RF, and DT. Based on the experimental SVM method using the kernel, degree, and C parameter, the best accuracy was obtained on the linear kernel with an accuracy of 80%, precision of 90%, recall of 86%, and an F1 score of 88%. This indicates that the linear kernel is the most sustainable for this dataset and can effectively classify the standard feedback. Additionally, the precision and recall value are also high, indicating that the model is able to accurately identify both positive and negative feedback. Next. Yeah, next. Next. Second experiment using the KNN methods. Based on the experimental KNN method using the N-Neighbors parameter, the best accuracy was obtained with 3 neighbors, achieving an accuracy of 63%, precision of 86%, recall of 81%, and an F1 score of 71%. Next. Next. Did experiment using random forest method. Based on the random forest experiment, the best accuracy was obtained using the N estimator and random state parameter. The optimal value were N estimator 30 and random state 40 or 60, resulting in an accuracy of 79%. Precision of 93%, recall of 80%, and F1 score of 86%. Random forest is a popular assembly learning method that utility multiple random forest decision tree to generate prediction. The use of multiple decision tree reduce the risk of overfitting and improve the accuracy of the model. In this study, the random forest algorithm was applied to achieve good result for the classification of certain feedback, demonstrating the effectiveness of this approach in natural language process tasks. Next. Fourth experiment using the decision tree methods. Based on the experiment with the decision tree methods, the best accuracy result are obtained with the criterion parameter 1 Gini and the max depth parameter 120, resulting in accuracy of 74% and a precision of 85%. Next. Result data process. The experimental result of the 4 methods produce process data using 70% training data and 30% testing data, which show that the SVM method has the highest F1 value of 88% and accuracy of 80% compared to the other methods. Next. Next. other experimental result using the 80% training data composition and 20% testing data show that the SPM method has better value with the highest F1 value of 90% and accuracy of 82% compared to other methods. Conclusion, in this study, we aim to classify student feedback as positive or negative by using four machine learning algorithm, SVM, KNN, RF, and GT. We evaluate the performance of this algorithm on a dataset of 30,233 feedback using metrics such as accuracy, precision, recall, and F1 score. The SVM method with a linear kernel had the best perform as evidenced by an accuracy of 82% and an F1 score of 90% using 80% training data and 20% testing data. We found that SVM with the pre-trained word embedding exhibit the highest accuracy of 82%, outperforming other algorithms. Next. Future work we will do to get the best result by using assembly learning to improve accuracy. Thank you.
Okay, thank you for the presentation. Maybe some participants have any questions? Raise your hand.
Okay, Mr. Abdul Munif.
Yeah, okay. Yeah.
Okay, thank you very much for this time for me. The question for Mr. Hamza. Can you hear my voice, Mr. Hamza? Okay, can you hear my voice?
I apologize that I can hear you because the signal is cut off.
Oh, okay, okay. I will to send from my chat.
Yes.
Okay. Okay. My question is first, what the preprocess that you use in your data set, and if we look for your get result, the best is SVM fit linear kernel. Maybe if the methods will compare with SVM non-linear kernel like RPF or using multi-kernel or polynomial, what the opinion for that? Okay, thank you, Mr. Hamza. Okay.
Yes, at the time of the experiment, we did not compare to SVM non-linear. I am compare with four methods: SVM, random forest, KNN, and session tree.
Maybe any correlation, Mr. Hamza, like your data type is linear or non-linear with so that you only use linear kernel. Maybe any reason or any initial analysis.
Can be written in chat.
Okay, Mr. Hamya is maybe it's very clear answer. Yes, enough. Okay.
I can hear.
No, okay. Why you? Okay, Mr. Munif, enough for the answer from Mr. Hamya. Okay, maybe it's clear.
Yes.
Time is enough. Yes.
Okay, thank you. Because the time is running out, so maybe we can conclude the question and answer session and we can move on to the next presenter. Okay, thank you, Mr. Imam and also Mr. Johnson for this brief for discussion. We can move on to the next presenter. The paper title is Optimization of Feature Weighting for epitope classification in T cells and cells using TBI1WICRI-PSOPRF. The presenter is Bapak Imam Polisudin. If you are ready, you can start the presentation.
Okay. Thank you very much for Mr. Abdul Munif. I will to present by my video. Okay. Okay, let me to share my screen. Okay, it's still disabled from host. Okay, thank you. Okay, oh, cepat. Okay, you can see my video.
Actually, if you are present, actually you can just present your slides. Actually.
Okay, Mr. Adumonif, you can see my video.
Yeah, I can see, but if you are present, actually it's better if you directly present by using your PowerPoint presentation.
Okay, I will to play this.
Yeah.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, thank you for this time for me to present my paper in international conference on information communication technology and system ICTS 2023. Please introduction to myself. My name is Imam Khalisodin. In these topics, I will to present my paper with entitled Optimization of Feature Weighting for Epitope Classification in B cell and cells using time variant inertia weight, acceleration coefficient, random injection, particle swarm optimization, stream learning machine. The content of my presentation. First is introduction with us the background how we do this research, and we compile from to get the literature review, and then research novelty like the combined time variant inertia weight, acceleration coefficient, and random injection. included inside in PSO algorithm and integrated with algorithm extreme learning machine. And next is result and discussion, and the last is conclusion and future work. Okay, in this introduction, we use the epitopes file. It's like a DNA sequence, as we can call peptide in the sequence of DNA of SARS-CoV-2 or SARS-CoV. Previous is one and other variant. In this biomolecular field, epitope classification is very difficult to classification of. If we use a machine to classifying, it's very hard to do that, because epitope is have very similar with non-epitope in sequence DNA of SARS-CoV. And in this study, we developed the machine learning approach to classification of epitope using a dataset from B-cell and SARS to predict material for SARS-CoV-2 vaccine. Because why we use two datasets? Because this material of SARS-CoV-2 vaccine is very similar from B-cell and SARS. And
Mr. Eko, are you still connected to us? Hello? Coba dicek ininya. Okay, Mr. Eko, can you still with us? Okay, maybe we wait 2-3 minutes. If he is not reconnecting, maybe we can move on to the next presenter. You can still start the time. So the finish time is still the same. You can start the timer, so you can see that the finish time is the same. Okay, Mr. Imam, can you hear my voice?
Yes, I can hear.
Yeah, your video is lagging and it's quite hard to follow your presentation. Your video is lagging and we are unable to follow your presentation, and there is no sound from your video. Can you just directly present your slides so we can make this presentation smoother?
Okay. Maybe I will to give the file video, or
No, just present from the PPT that you already made.
okay, I will to present live. Okay. Okay, thank you very much for Mr. Abdul Munif. Sorry for my video is not clear for the running online. Okay, I will to introduce to myself. My name is Imam Holisodin, and I
Maybe you
will
can
to
continue after the introduction. Your video is stopped after the introduction.
okay. Okay. After introduction is about the feature weighting and hyperparameter tuning. We focus to get the feature weight optimal of each dataset for pixel and SARS. And hyperparameter is focused for the input weight and to bias for classifier model, namely extreme learning machine. Uh, okay, for the main challenge in the feature weighting and hyperparameter is many large number of parameter value of candidate. So if we doing like using brute force or using random is not recommended. So for the solution, we will discuss in the my contribution. Okay. Next is about my purpose or contribution of this our research. We call using time variant inertia weight, and we combine using acceleration coefficient, and the last is random injection. We include inside in particle swarm optimization, and then we use combine using a classifier model, namely extreme learning machine. So if we look based on this beside in this figure, this is step by step for our contribution, like start from initial random population, and then calculation fitness age particle as a candidate solution of feature weighting optimization and hyperparameter tuning for ELM. And then update velocity, update position until iteration maximum. And for the dataset, we divide into two sides, training and testing, with 80% and 20%. Training for 18% and 20% for testing. And for the specification of dataset, we use two dataset, BCL and SAF. It contain 9 column feature and 1 column target. And in the 1 column target is contain 2 class, 0 for class non-epitope, and 1 is for class epitope. This is assembly as for BCL or for the dataset charge, included 9 column and 1 column target. And for the representation of our particle of PSO that we will use for optimization, we divide into 2 clusters. Cluster 1 is optimized for feature weighting to multiply of each variable of dataset for BCL and SARS. And the cluster 2 is for optimize or get the best value for input weight and bias from of ELM algorithm as a classifier model. And we use evaluation function as a fitness equal accuracy, like this slide. Okay, next is based our testing the results, and the first is we using BCL dataset, and we reach the convergent condition based maximum iteration on 85 280 for BCL, and we obtain starting the stable condition is 166 iteration for BCL. So it's very little for the installation at get fast condition for the get base of variable. And for the stars, we achieve the starting convergent condition in 177 iteration. And if we compare with a few previous algorithm like original ELM or random forest original, we achieve for the B cell is 0.737, and for the SAS we achieve accuracy 0.913, and in the B cell we only use a little improvement, but in SAS we can get the higher improvement if we compare with previous algorithm. And for the conclusion, the TVIWACRI PSOLM algorithm has been successful to implement for B cell and Sarkov epitope for classification case. And the essence of the basic of optimization is about the AC automation without using to do manual step for get feature weighting or hyperparameter of the for the model classifier like the SVM. And for the achievement result, we get the range about the average accuracy 8.4% in all dataset. Okay, thank you very much for this attention. We will back to Mr. Abdul Monif. Okay.
Okay, thank you for the presentation. We can move on to the next question and answer session. If any of you have a question regarding this topic? Okay, any question? We still have 1 minute left for this presentation.
Okay. Okay, thank you very much, Mr. Abdul Munif. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Yeah, okay, maybe we can move on to the next presenter, which is myself. Okay. Selesai. Okay, thank you for the opportunity. I would like to present our research with the title Deep Learning Deployment on Big Data Infrastructure using PantiSpark with case study of COVID-19 detection using X-ray image. Okay, the author of this paper is myself, Abdul Munif, and also the academic from Department of Informatics, ICTS. Okay, yes. Okay, so first of all, I would like to introduce about the outline of my presentation. I will open with the introduction and also the problem definition, methodology, experiments, and also the conclusions. Okay, so maybe you can see from the screen that we would like to process the data like X-ray image about the COVID-19 disease, so we can predict whether this image is COVID-19 cases or any other cases. Okay, we would like to use several big data tools like Apache Spark, Hadoop, and also we combine deep learning, which is the deep learning frameworks on top of the big data architecture. Next. Okay, so maybe basically this is a case study in our previous COVID-19 outbreak, which is in the last 2021 there are a lot of more than almost 190 millions of people have been contracted by this virus. And usually for the COVID-19 detection, there are several methods to detect COVID-19 disease. The four of them is using the chemical reaction. The first one is PCR. It is the common one and also the gold standard for detecting the COVID-19. And then we also have antigen or rapid antigen tests. And then we also have antibody tests when we can detect the antibody that produced by the immune system to respond to this virus. Or you can also have improvement of the basic PCR, which is real-time RT-PCR, where it can convert the viral DNA to DNA for the detection. It is much more faster than the previous one. These four methods is usually, we still need to do biochemical processing, and it takes time. And however, although it is very accurate, but we also have some other approach like machine learning models, where we can use the medical imaging data to create machine learning or deep learning models to detect COVID-19 diseases. Because as we know that COVID is attacking our lung, so that's why if we have been contracted by this virus, our lung have a different appearance compared to the healthy lung. Okay, next. Okay, so regarding for this machine learning or deep learning model, usually the deep learning can be improved or maybe can be speed up by using the GPU. But also in the current developments, instead of using GPU, we can also use the big data infrastructure. So if you already have like Apache Hadoop cluster or maybe Apache Spark cluster, actually you can also run the deep learning models on top of those architectures. So we not really rely on the GPU. So it means that if you already invest on the big data infrastructure, you don't have to invest on GPU to run your deep learning models. It can be achieved by using the Apache Spark and also the deep learning libraries, so we can alleviate the burden of single computer processing into the cluster processing, which is usually faster than only single computer. Next. Okay, so maybe I'll move on to the Apache Spark. Actually, why it can perform faster compared to our single computer process? Because it usually happens that it consists of at least 2 workers and also 1 master nodes. So if you have any computational programs, actually you can submit to the Spark context, and then the cluster will divide the computation into several workers. So hopefully by using this approach, we can perform computation faster compared to only single computer. Next. And also, based on the current developments, it is also possible to deploy big deep learning models on top of big data architecture. So instead of using GPU, we are using the big data cluster that we already have. This library is actively developed. And then there are several variants of these libraries. Actually, we will use the GLIC libraries, this one, because we want to run this deep learning models on top of Apache Spark cluster, and they already provide us with the GLIC libraries. Next. Okay, so the problem is we want to automate the building of big data architecture and deep learning models, and then we also want to try to use this architecture to detect COVID-19 cases using just X-ray image. Okay, so this is our architecture of the big data infrastructure. We will have Hadoop cluster to be used as our data storage, and then we also have Apache Spark and Big Data libraries as our worker. So our storage is saved inside the distributed storage Hadoop, and then the worker will take a look at the data inside of the cluster. And also the Spark cluster and Big Data cluster is also built on top of the cluster more than one computer. And hopefully by using this approach, we can speed up the computation. Okay, because of the limitation of our resource, actually we only have 9 servers. So we have a combination to get the better result, which one is the best one. So for example, we can increase the number of Spark worker, or maybe we can increase the data nodes, or maybe the storage nodes on the storage cluster. Okay, next. And then in terms of the deep learning architecture, we are using the pre-trained models. Actually, we would like to use three different pre-trained model, which is the Inception 1, Inception 2, and also Transnet 50. This pre-trained model can be directly used to process our image. And then we use the classification from the Apache Spark or the Epic libraries. So after we reading the data, we're using a neural network image reader from the big data. Then this data can be processed and then to be as an input for our pre-trained model. And then after this data has been processed by our pre-trained model, then this data will be inputted into the pipeline inside Apache Spark. And then this Apache Spark will do the estimation and then do the classification. Okay, so these deep learning models, we are using Inception V1, V3, and also Transnet 50. But based on our experiment, the successful models that has been successfully deployed is only Inception V1. The other one, the rest of the model has not been successfully developed, maybe due to the limitation in the library and also in our architecture. Okay, here this is the basic Apache Spark classification or estimation in terms of classification of image. From the raw data, we will transform the data and then we put it inside the estimator. And then this estimator will be transformed again, and this transformation will be put it inside the estimator. This estimator will classify the image based on our data. So as always, we will separate the data from training and also the testing. And then after the model learn from the training data, and then finally we use those model to predict the testing data. Next. Okay, so the experiments, maybe next, yeah. We tried the experiment from this data set. It consists of 4 types of classes, which is COVID-19, normal, low complexity, and also viral pneumonia. We try to use 2 different approaches. The first one, we only considering the normal and also the disease part. So we only have 2 classes. And then we also use all of the classes, 4 classes, and then we can compare which one has the most accurate prediction. Next. And then we also try with a different architecture. We found that the Inception 50 and Transnet 50 is unable to be deployed because some of the out of memory errors. Because maybe the model is quite complex and our library cannot handle that. So that's why from this research we only use the Inception V1 as our pre-trained model to be used for classification. Okay, next. Okay, and also we designed the 16 types of experiments, verifying the number of workers, page size, and also the epoch. We have 16 different models, and then the result can be seen from the next slides. Next. Okay, here, based on our experiment, we found that the highest accuracy for our models is around 98%. However, for the faster learning times, we found from the experimental team, which is around 27 minutes to train and also to classify those models. So it is very pretty good. If we are only using one single computer, maybe we have more than 10 hours to run all of our models. Okay, thanks. And we also try to detect the throughput for our system because this system is preset inside the cluster, and of course there are some of the network delays and so on. We found that if you are using higher bits or maybe higher base size, usually it produces inconsistent result, inconsistent traffic. That's why in our experiment we also try to reduce our page size, and it is proven that if we reduce the page size, the accuracy is higher compared to our higher page size. Okay, maybe the last one from our conclusion and suggestion. We successfully implement the big data architecture and also deep learning by using Apache Spark and also by using the Ansibles. For the big deep learning process, we can put the big deep learning library on top of the Spark cluster, so we can speed up the classification process, and maybe it's comparable to the GPU. However, because we don't have any GPU as our benchmark, maybe we cannot show you the result of this comparison. And finally, we also have the deployed inception P1 and the rest of the real-time model has not been successfully implemented due to the memory error. Okay, next, maybe for the discussion or maybe for the research. Next. Yeah, we found that this exploration like the newer big data libraries. If I'm not mistaken, last week because this came in last year, there are a lot of improvement in the big data library. The version is higher. We can try maybe for different version, and hopefully by using this different version, maybe those other real-time model can be deployed on top of the big data environments. And also there are possibles using Docker and also Kubernetes, and also we can mitigate the issue of out-of-memory problems by increasing the cluster computational powers. Okay, I think that's all for my presentation. Maybe if you have any question, please raise your hand. Yeah.
What is your current assumption on the performance comparison between using a existing big data accelerator versus just using a GPU? And then what is the difference in cost on deploying using these two methods?
Okay, I think in terms of because for the price, because we are using cloud computing, actually we only need to pay as we need it. So, for example, after we finish the experiments, maybe it's only takes 3 hours, for example, then we destroy the cluster. Actually, the cost of running this experiment is quite low compared to if we want to buy the new GPU, for example. But for the performance wise, because I cannot compare them because I don't have any GPU, maybe I cannot answer about those comparisons. But I believe that my assumption this should be this big data architecture can also speed up the process of deep learning models compared to the GPU. So my assumption is like that because we varying the amount of the worker. It shows that if we are increasing the workers, the running times are much more faster compared with the only a few workers. Okay. Maybe any question?
Okay, Mr. Abdul Munif.
Yeah.
Let me to two questions. The first is if we measure the size of the file dataset how the big size for the dataset, file dataset. So you decide use big data ecosystem, and in the any scenario to compare non-big data ecosystem versus multi-node Spark versus multi-node in Hadoop. Okay, thank you, Mr. Munif.
Okay, yeah, thank you. All this data actually it's around 10 gigabytes of image, so it's pretty large. And we save those data inside the Hadoop cluster. If the first question, I think that's one. And why I decided to use big data ecosystem because I already have this ecosystem, and then we would like to try to deploy the deep learning on top of those architecture actually. So it is not entirely based on how is our data because our idea is how we can deploy the deep learning on top of our big data, our existing big data architecture. I think that's my answer. And then in terms of the second question, any standard to compare on big data and not. This is not our research goal on this experiment on this paper. Actually, it is only one part of our whole research. Actually, so on this research, we only needs to we need only to show the result that we successfully developed the architecture of big data, and then we put the deep learning models on top of those big data. So I think thank you for the question. Actually, is on different on the different seasons.
Okay, thank you for answer, Mr. Munif. Okay.
Okay, and then also from the Jane, thank you for the suggestion. It's also not covered in this experiment. It is the IUC score. So this also can we also have a different approach for this because I also can see that there are a lot of imbalance data, but it is not covered in this research. Will be covered in the another research. Okay, thank you. I already considered this method. Thank you for your inputs. Okay, maybe any other question for this presentation? Okay, no? Okay, thank you. Maybe we can move on to the last Okay, the last presenter is for paper what influences intention to buy cosmetics products through online commerce with biometric analysis. This is from Nabila Sari, Renina Difatif, and also Apol Tribadi Supriyadi. This will be presented by Ms. Nabila Sari. Are you ready?
Yes, sir.
Okay, yeah, you can start your presentation.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen, and fellow students who are able to attend the ICTS conference today. Allow me to introduce myself. I'm Nabila Lansari, a student from Information System Department of ICTS. During this occasion, I will provide a general overview of my paper, what influences intention to buy cosmetic product through online commerce bibliometric analysis, with Mrs. Reni Nadlifatin and Mr. Apol, who have contributed to the completion of this paper. Next. So just get to the point background of this paper. Certainly, there are several important factors that underlie the writing of this paper that need to be addressed. First, cosmetic refers to product meant for external use on the human body like skin, hair, nails, lips, and oral care. They are used primarily for cleansing, adding fragrance, enhancing appearance, controlling body odor, or maintaining body health. The consumer cosmetic market in Indonesia offers opportunities due to factors such as growing population, change in consumer lifestyle, increased focus on beauty, technological advancement, and others. And e-commerce means buying and selling product or service online through the internet or other computer network. There's any challenges faced by cosmetic sellers online include strong competition, building trust with customers, slow delivery, return policies, dealing with fake product, and more. Because of the problems, so this research aims to find out what factor influence people interested in buying cosmetic products online. Next. Yes, for method on this paper piece, we define what research question definition. What factor affect customer interest in purchasing cosmetic factors on online shopping platform? So for inclusion and exclusion criteria, we will include research paper published in English between 2018 and 2023 that investigate the factor influencing customer interest in buying cosmetic product on online platform with a journal quartile first rating. We will exclude duplicate paper and does not written in English. For literature research, we conduct our research using relevant keywords such as broadcast interest, cosmetic, online shopping platform, and their variation. And last is article selection and evaluation. Extract data will include information such as research objective, methodology, variables under investigation, key findings, and conclusion. So the extract data will be systematically analyzed, and the main finding from each article will be synthesis. This finding will then be categorized and linked to the research question. The result of the data analyzed and synthesis will be interpreted to provide a comprehensive understanding of the factor influencing customer purchasing interest in cosmetic product on online platform. Next. The research mapping was conducted using EOP to retrieve 1,000 journals, followed by employing force viewers to visualize the emergence pattern. Out of these, 70 journals were initially selected. Subsequently, the selection was narrowed down, leading to the identification of notable journals such as the Journal of Retailing and Customer Service, Information and Management, Electronic Commerce Research and Application, and more. Further advance result in a final selection of 30 journals focusing on paper most relevant to the topic. It is evident that there are a lack of strong interconnection among the topic, as indicated by the disparate colors and their separation into non-contiguous area. Consequently, research concerning the interconnected in this topic remaining relatively scarce. Furthermore, among the 30 selected paper, it is that significant portion of early research predominantly address topic related to e-commerce. Next. For research and discussion from this paper, we find 5 factors influencing customer buying interest in cosmetic. So first, consumer trust in e-commerce platform is significantly influenced by several key factors. Firstly, security and data privacy are crucial. With consumers seeking protection for their personal information, the presence of strong security protocols and privacy policies can enhance trust. Additionally, a platform reputation plays a significant role. Consumers prefer platforms with a good reputation for reliability, product quality, and customer satisfaction. Reliable delivery service are also important, as customers want to ensure timely and secure delivery. Lastly, effective quality assurance mechanism and return policy can boost consumer trust, providing assurance of quality product and easy returns if needed. Second is about customer review and user recommendations. Have a significant impact on purchasing interest. Research show that positive reviews increase buying interest by providing positive product information and building customer trust. Conversely, negative review can reduce buying interest by eroding consumer trust. Trustworthy user recommendation also play a crucial role in shaping customer perception of product quality and platform reliability. When consumers see recommendation from user they trust, it can enhance their perception of product quality and trigger higher buying interest. Therefore, both positive customer reviews and positive user recommendation have a positive impact on buying interest, while negative reviews can have a negative impact. Third, about price and a promotional factor significantly influence customer buying interest in e-commerce or online platform. Competitive price, like discount and special offer, enhance buying interest. Customers are attracted to low price and enticing offer, but also consider product quality and brand trustworthy. E-commerce managers should be responsive to user review and recommendation. Next, fourth, product quality and brand perception. Fourth, product quality and brand perception play a significant role in determining customer buying interest. Especially in the cosmetic industry, cosmetics tend to choose products perceived as high quality and from trusted brands. Product quality and brand reputation influence the perception of product value and customer buying interest. If a product is seen as high quality and the brand has a good reputation, customers are more likely to purchase it. Conversely, if a product is perceived as low quality or the brand is less trust, customer buying interest may decrease. Therefore, a commerce platform manager needs to focus on strengthening brand perception and maintaining consistent product quality through effective branding strategies, clear communication of product advantage, and quality maintenance policy. And five, social factor and beauty trend play a crucial role influencing customer buying interest. Research indicate that the influence of celebrities, influencers, and current beauty trends significantly impact customer purchase decision. In the era of social media and influencer popularity, customers tend to seek product recommendation from famous figures or influencers they follow. When celebrity or influencers endorse or use a specific product, it can change customer perception of that product, ultimately increasing their buying interest. Additionally, beauty trend also play a vital role in influencing customer buying interest. Consumers now prefer products that align with the latest trend in the beauty industry. They want to a professional, fashionable, and adhere to current beauty standard. Next. At the same time, we find some research gap. There is 5 research gap. First, there is a need for further research to understand the impact of environmental factor or external factor, such as website design and the quality of delivery service on customer purchasing interest on online platform. Second, customer segmentation. In the context of customer interest in buying cosmetic product on online platform, in-depth research is required regarding customer segmentation based on demographic factor, shopping habits, brand preference, and product usage goal. This will help in designing more effective marketing strategies. And third, brand perception influence. Further research on the influence of brand on customer purchasing interest on e-commerce platform, especially in the cosmetic industry, and the factor that affect brand perception can provide deeper insights. And then there is customer engagement. Detailed research is needed on the relationship between customer engagement levels on e-commerce or online platform and their impact on purchasing interest. And for the last gap is comparison of e-commerce platform or online platform, which is comparing a commerce platform or online platform in the context of customer interest in cosmetic product is limited. As most current research focus on just specific platform like one platform. And next. So for the last is conclusion. Factor influencing podcast interest include trust, user reviews, and recommendation, price and promotion impact, product quality and brand, as well as social factors and beauty trends. A deep understanding of this factor can assist industry professionals in crafting effective marketing strategies to attract and retain customers. Research gaps such as environmental factor, customer segmentation, brand perception influence, customer engagement, and comparison between e-commerce platform exist. Like before, while existing research provides valuable insight, there are several gaps that need to be addressed in the future. More in-depth research can further enhance our understanding of customer purchase interest in cosmetic products on online platform. Next. So that's all I can tell about my paper. Sorry to any mistake I did. Thank you, Mr. Abdul Manif.
Okay, yeah, thank you for the presenter. Maybe we still have 2 minutes for the question and answer session. Maybe from the attendees still have a question for these topics. Yeah. Yeah, we have one question. Yeah.
Yeah, I think this is a very interesting research. I want to ask for, is there any order for the factors in which one's cosmetic product? And then the session question, how to determine if the factors can be categorized as have high significance and influence the cosmetic product.
Sorry, can you repeat please? Because I have a bit of signal on my place right now, and your voice is just so far away.
Okay. Maybe I just maybe I can you hear my voice? Sorry.
Yes.
Yeah. Okay. Maybe I will retell the question. The first one is, do you have any certain order of the factor that influence about this buying cosmetic products? Sorry, the order of the factor. Is that correct? Yeah. Maybe for the first question first, maybe you can give some answer.
Sorry, sir. I can be clear to hear that. Can I can I don't really hear anything.
Maybe I will help you with the question from the
Okay.
Okay, the second one, how we can categorize.
What is the order? Okay. The order it's like priority, right? Or
Yeah.
okay. How can we categorize so that have higher influence? Okay. Okay. So before I answer, I'm sorry because I'm sorry, Mr. Abdul Munir. Because I'm not really fluent in English. Can I change to bahasa to answer that question, right?
Yeah, if it is more comfortable, yes, you can use bahasa.
Yes, thank you. For I don't know, the participant, I will answer what is order and how we can categorize which factor that have high influence. From the sorry. Saya coba menggunakan bahasa Indonesia, permisi. Berdasarkan riset atau penelitian yang telah kami lakukan, belum ada urutan untuk mengkategorisasinya. Tetapi berdasarkan proses yang telah dilakukan, bisa menggunakan kemunculan terbanyak dari faktor-faktor yang telah dibahas pada penelitian sebelumnya, karena di sini juga mention beberapa faktor yang ditemukan dari penelitian sebelumnya, dan yang paling sering muncul itulah yang diambil. Berdasarkan urutan terbanyak itulah, seperti yang telah saya tampilkan tadi, itu sesuai dengan jumlah yang muncul. Kemungkinan yang paling banyak muncul 5 faktor tersebut. Permisi, apakah suara saya masuk?
Maybe I have a follow-up question. So you said that the number of the occurrence, and then you can decide which factor that can appear as the influence. How we can buy the cosmetics. So actually, does it mean that we can also order based on the number of occurrence? So we can put that the factor that have higher occurrence may be the most important factor compared to the other factor.
How I can compare the other factor to other factors? Excuse me, Mister?
You said that you found the factor based on the number of
Excuse me,
occurrence.
Mister? Excuse
Maybe I
me.
will put the question on the chat.
Number of points can be used to decide whether it means it's possible to use as the order of the importance of the factors. I think that's not really well to use, but sorry, I change to bahasa again. Mungkin penggunaan metode seperti itu belum tentu menentukan bahwa pentingnya dari faktor itu tuh berdasarkan kemunculan yang paling sering, tetapi berdasarkan hasil dari penelitian sebelumnya, faktor-faktor yang telah disebutkan itu adalah faktor yang paling sering muncul, sehingga beberapa faktor yang lainnya yang di luar faktor-faktor tersebut itu belum disebutkan, tetapi tidak menutup kemungkinan bahwa faktor-faktor lainnya yang mungkin belum diselidiki lebih lanjut, belum diteliti lebih lanjut, itu bisa menjadi faktor yang sebenarnya penting tetapi belum didalami lebih lanjut oleh para peneliti sebelumnya. Thank you, Sir.
Okay, are you satisfied with the answer? Okay, yeah, I think that's maybe our time is also already up. So maybe this question also concludes our presentation session for this paper. Maybe we can give applause for the. Okay, thank you for the presentation. Because our time is finished, maybe we will close this presentation session. Okay, thank you for your participation. And after this, please come to the 107 rooms to do the closing, and then we can do the photo session after that. We will have closing statement at 4 p.m. So please join to the room 107. Okay. Thank you. Yeah. Thank you in your other location. Thank you.